And we're now a global player with $100 million revenue globally and operations in multiple countries, as you can see there. We're an activated carbon company, first and foremost, and we work with customers across our territories to help solve complex environmental challenges. A little bit about PFAS. People are getting more and more familiar with this. There's a good diagram on the right-hand side that shows the PFAS cycle. These 14 or so thousand synthetic compounds that have been around for over 70 years, used in things like a non-stick coating, firefighting foam, textile coatings, food packaging, lots and lots of industrial and domestic applications. They're very long-lived, they don't break down readily, and that's why they're such a widespread concern in the environment, both in terms of drinking water, recycling of processed water, wastewater, groundwater. These things pop up everywhere, the waste industry as well. So yeah, they circulate around the environment. They're very mobile as well, as you can demonstrated by that graphic. A good case in point, there was a case recently where 11 executives from an Italian chemical company were jailed for a deliberate pollution of PFAS into their local river. So it's in the headlines, it's grabbing all the wrong headlines, but we're here to say that there is a solution and we want to help companies solve their challenges.
So across the UK, across our UK laboratories, Puregen have a range of different detection equipment, including our LCMS at our lab in Sheffield, capable of detecting low levels of 49 different PFAS molecules. The UK Drinking Water Regulator has set a precautionary guideline to drinking water utilities of 0.1 micrograms per litre for the sum of 48 named PFAS molecules, and are expected to implement these companies are expected to implement emergency measures if PFAS exceed these limits. So there are currently no such guidelines for the removal of PFAS from wastewater. However, we are getting many requests to support where the EA are requesting that some wastewater producers or processors implement a solution to bring the concentrations of PFAS down to a similar level before discharging to the environment. We consider it imperative that utilities and industries must design future-proof systems and not be limited to today's guidelines. This is a moving picture, so will help protect reputations and do the right thing for the environment and public health.
So we've outlined the background to it. We'd like to now talk in more detail about our solution in terms of sustainable abatement and destruction of PFAS. Initially, I'll start by explaining what activated carbon is, because some people are very familiar with it. Some people may have heard of it and not know the detail. So we just have one slide to say what it is we're talking about as our solution. Activated carbon is a pure form of carbon with a very high surface area, made up of microscopic pores. You can see a scanning electron microscope image there on the right. You can see the pore structure. We say that a dessert spoon of activated carbon has the surface area of 1.5 football pitches made up of those pores. So you can see why such a high surface area makes it so good as a filtration medium. Different raw materials are used, typically bituminous coal, coconut shells, certain types of wood. And each of those raw materials gives you a different property and different characteristics, different applications. Physical forms, you might be familiar with GAC for granular, PAC for powder, or pellets. The image at the bottom, you can see a large GAC at the front and extruded pellets at the back. Both of those grades would typically be used for gas phase applications like odor control or biogas. The way it works, you typically have a deep bed of activated carbon. You pass your fluid, so a liquid or a gas, through the bed of carbon, and the impurities are trapped in those pores by a process called adsorption. It's a reversible process, so if you apply heat to that system, you can desorb those contaminants, recycle the carbon, and destroy the contaminants, and that's the basis for our PFAS destruction as well. There are many hundreds of applications. Obviously, we're focusing on PFAS today, but more broadly, you think in the liquid phase, you have drinking water, wastewater, groundwater remediation, also things like edible oil, food and beverage, chemical purification, so many liquid phase applications. And then on the gas phase, classically odor control, VOC, so volatile organic compound abatement, biogas, biomethane, respirators, so many gas phase applications too, and we're active in all of those. Generally speaking, the applications are driven by legislation, so pure water, clean air, and more renewable energy, and that's what's driven our growth certainly in recent years. Luckily for us, GAC granular activated carbon has been identified as the best available technique for PFAS removal. And more importantly, we have developed unique service modified versions that specifically target PFAS compounds that Nick will talk about more in a moment.
Yeah.
So activated carbon is. Zooming out a bit, as I alluded to in the previous slide, it's used for many, many applications for purification. What does it remove? We split it into two broad groups. You've got the organic chemicals, which is carbon chemistry on the left, and inorganic, so the rest on the right. The reason for that is so inorganics like hydrogen sulfide, H2S, and ammonia, which you'll find in odor control or biogas applications. You need a chemical impregnance on the activated carbon to react with those inorganics. They don't readily absorb on standard carbons. But on the organic side, you generally have a standard range of activated carbons. You've got the gas phase, you've got your volatile organics, your VOCs, siloxanes in biogas, formaldehyde, benzene, lots of other VOCs. I put PFAS in brackets there because do remember that short chain PFAS are volatile. They do exist in the gas phase, and we have a very, very good case study where we've helped the customer with gas phase PFAS abatement. And then on liquid phase there, your classical water treatment, you've got these terms for the total organic loading, your TOC, your total organic carbon, your chemical oxygen demand. So that's the total organic loading in the water matrix, and either drinking water or wastewater. But within that would include, pharmaceuticals, pesticides, herbicides, and PFAS, new kid on the block. So that gives you a broad brush of what we're involved with. Obviously, we're focusing mainly on PFAS today. That is the hot topic. So our solution we call search, capture, and destroy, and I'll hand over to Nick to go into a little bit more detail about each of those steps.
Thank you. Okay, so the first part of PureGen's solution is to search for the PFAS. We have lab equipment included in our state-of-the-art LCMS, capable of including our state-of-the-art LCMS, capable of detecting 49 PFAS molecules to very, very low levels. This allows us to check for the presence of PFAS in the customer's process. By understanding the chemistry of an individual water, we're able to identify which particular carbons would be most suitable for effective treatment. Our FiltraPure CH range of carbons have shown enhanced performance compared to the traditional activated carbons supplied into the marketplace. We are unique in the UK activated carbon industry in having a UK R&D team headed by my colleague Dr. Andy Gill, who has spent a huge amount of time and resource to develop our novel PFAS products, the FiltraPure CH range. We continue to allocate substantial resource to help with our knowledge of the PFAS challenge and to continuously improve our products and services. The next part of our PFAS solution is to capture the PFAS. Our sector has generally offered standard GAC for this application, but as mentioned on the previous slide, PureGen have developed a novel range of activated carbons specifically designed to capture PFAS to a greater degree than traditional GAC. Our FiltraPure CH range offers a unique surface chemistry which encourages greater affinity between the PFAS molecule and the surface of the carbon. So on a molecular scale, surface reactions occur where the carbon chain within the PFAS molecule is exposed, meaning that it absorbs more strongly to the activated carbon surface. Now, this enhanced attraction means that the carbons that we offer for PFAS removal typically last longer than traditional carbons. One unique selling point of our PFAS solution is that we can take back and reactivate spent carbon media used within the drinking water and wastewater systems containing high levels of PFAS and POPs, and destroying the PFAS in the process. This is also true for gas phase applications. So a key element of the capture part of our solution is the ability to quickly supply mobile filters to house the carbon media and also to transport. All of our filters have been designed and built by PureGen Engineering. We offer mobile filtration solutions for both the liquid and gas phase, ranging from 2 meter cubed volume and to 22 meter cubed volume in the liquid phase, treating flows of up to 100 meters cubed an hour, and 2 meter cubed and 30 meter cubed volume in the gas phase, treating flows of up to 60,000 meters cubed per hour. Our mobile filters offer a convenient plug and play solution, allowing for quick startup and shutdown, and are modular so can easily be incorporated into existing infrastructure. There is no limit, space allowing, to the number of mobile filters that can be used in a particular process. Many of our customers will have multiple filters on site to treat their water or gas. Our mobile filters are low capex, our low capex rental solution, meaning that there is minimal initial investment required for installation. This makes them ideal as a permanent long-term option, or if there's a temporary contamination issue, they can easily be hired and off-hired as a short-term fix. The small footprint make them ideal for small or large sites, The filters are delivered containing activated carbon, and once used and spent, are switched with a new unit containing fresh carbon. The spent unit is then taken away to our service centre before the media is sent to our Immingham facility. This allows for so the spent media will be reactivated at the Immingham facility. Allows for a completely clean process, eliminating the need for potential harmful spent carbon handling on site and minimises disruption and downtime for the customer. So the third and final part of PureGen's PFAS solution is to destroy the PFAS. We have already mentioned that we can take back and recycle spent carbons containing high levels of PFAS. It is within this reactivation process and the additional three-stage abatement system where the PFAS is completely destroyed. Reactivation will destroy some, but not all of the PFAS. So we know that reactivation completely separates PFAS from the activated carbon media, and we will discuss this as a case study shortly. Although some of the PFAS is destroyed in the thermal oxidizer, this part of the reactivation process does not sort of destroy 100% of the PFAS. The off gas is passed through a three-stage abatement system, which completely destroys the PFAS. Independent testing has shown that we do not add PFAS back into the environment, either through our gas emissions or wastewater emissions, and that we have completely separated the PFAS from the activated carbon and destroyed it.
So we wanted to get some data to prove that. It's quite a bold claim. So we had some testing, independent testing done on our green and amber kiln. Green kilns for drinking water, amber for industrial. CR1 is our green kiln. We took a test sample of the background air in the labs. This is a clean environment, and it measured 19 nanograms per cubic meter. That's the PFAS in the air that we're all breathing in every day, and this is in a clean environment. The stack emissions from our green kiln were at 22 nanograms per cubic meter, with an uncertainty you can see there of plus or minus 27%. A nanogram is 10 to the minus 9 of a gram. So these very, very low levels, we can confidently say we're not emitting any more PFAS than is in the air already. We can't take it out of the atmosphere, but we can stop it leaving our process. Liquid phase emissions, same story. We tested multiple wastewater samples, and there was zero PFAS in the wastewater above the site's drinking water inlet level. In fact, in some cases, our wastewater is cleaner than the drinking water coming onto the site. So these multiple tests that we've done offer conclusive proof that our cradle-to-grave technology removes and destroys PFAS group chemicals. So we wanted to show that proof. We're working with lots of sectors. As I mentioned at the start, everyone is concerned with PFAS. We're delivering successful solutions into the drinking water sector, wastewater, remediation, the chemical industry, so the people actually making and using PFAS. It crosses over into air and VOC emissions. As I mentioned before, PFAS can be volatile. We've got a very good case study there, actually shown in one of those photos. And we're working with the food and pharmaceutical sector because everyone has a concern. So to give you a few case studies of where we're working, starting at the top right, this is the town in France called Rumilly, near a very well-known French cookware manufacturer where they obviously have a PFAS issue in the drinking water. The customer installed one of our filters, the light blue one, a competitor's filter, the dark grey one, back in April 2024, so over 18 months ago. PFAS has been detected in the outlet of the competitor's filter. They've had breakthrough, as we call it, so they've had to change that carbon out. Our filter is still going strong with the original load of carbon, so it proves our carbons last longer. And this was an early iteration of our advanced carbon. Since then, we've made many improvements to the range, offering enhanced performance above that. The case study next to it is another one from France, interestingly, an airport near the German border where the wastewater at the airport was polluting the local drinking water supply. And they installed 6 mobile carbon filters, 3 of ours, the light blue ones, and 3 of our competitors' ones, a light grey. Obviously, they will contain different carbons, and time will tell about the breakthrough. But we're very confident, based on as Nick alluded to, that our carbons do perform better, take out more PFAS, and last longer. But we'll work with the customer to look at those details. The bottom left there is a gas phase application. These are our high flow HF20V filters, taking very, very large quantities of gas. This is a chemical plant that use and make PFAS, and I'll talk in more detail about that case study in a moment. And the bottom right, that's a bulk carrier that can deliver powder activated carbon if required. So some projects where they're encapsulating and stabilizing soil, they actually inject PAC. We can grind out ourselves in multiple locations in Europe, and we can deliver in bulk. So, forms of barrier treatment in the ground. Obviously, that doesn't fit in with our service model of putting GAC or pellets into a mobile filter and then recycling it, reactivating it. You can't recycle PAC, certainly can't recycle it when it's buried in the ground. But if a customer is doing that type of project, we can support that, and we do have case studies of that as well.
Yeah. So previously, we spoke about how we can completely separate PFAS from the activated carbon media within the reactivation process to enable us to deliver back a completely PFAS-free product to the customer, a PFAS-free reactivated product to the customer. Now, this example here was from spent carbon media used in a wastewater process containing 8 PFAS species on a chemical site. The customer rented a large Aquasorber 22-100 unit to remove PFAS from their wastewater, and a photo of a unit is there in the photos on the right. The table on the bottom right of the slide shows data from a water extract of the spent and reactivated carbon. As you can see, on the bottom left-hand column, there were thousands of nanograms per litre of 7 of the PFAS species within the wastewater and 5.8 million nanograms per litre of PFHXA, which is perfluorohexanoic acid. So this is a moderately difficult to remove PFAS molecule with a carboxylic acid head group, making removal more of a challenge. The high levels of this particular PFAS indicates how well the activated carbon's performed. The column on the right-hand side shows levels of each of the 8 PFAS species as being below detectable limits, in the extract as being below detectable limits, showing how well we can separate the PFAS from the spent media within the kiln. Here we have this is an example of a large remediation project where 6 of our mobile units were rented by the customer. You can see from the photo that our units are being used in conjunction with other technologies to provide a full solution to the customer. Our mobile filters have been installed to be the final polishing step of this particular process to polish down the groundwater to suitable discharge limits.
Oh yeah, an interesting thing about this. We mentioned before the modular benefit of having mobile filters as opposed to fixed filters. This project started off with 4, but they had a higher flow than expected, so they added 2 more into the process. It was a very easy change, very quick and easy change. We delivered 2 more to that site. So again, the benefits of a modular, scalable approach of using mobile filters. This is the gas phase case study I alluded to earlier. This is a chemical plant that make and use PFAS. They're producing high performance elastomers for aerospace and automotive. And they had a real issue and they need to comply with local strict air emissions regulations. We believe this is the first of its type in terms of projects. This was in France. After initial trial to identify the optimum activated carbon, we installed 4 of our largest filters, the HF20V. That's a high flow 20 cubic meter vertical filter. You can see them in a row there. And they're basically taking the entire volume of air from inside the factory and putting it through the carbon filters. They've been operational since August 2024. We're working very closely with the customer in a partnership approach, and the performance is exceeding the regulatory requirements imposed on them. They're achieving greater than 90% capture of the fluorinated substance. And crucially, and kind of unique to us, we can take back all of the spent material to our UK reactivation facility, recycle it, and use it again in the customer process. So that's a great case study where we worked in collaboration with the customer to solve a really difficult challenge and come up with a solution that satisfies everybody.
Okay, so our flagship Filter Pure CH range of carbons are now have been developed and are now being used in multiple water treatment sites across the UK and in Europe to great effect. This case study shows where our full cradle-to-grave solution for our Filter Pure CH carbons is already very attractive to companies required to remove PFAS from water. By reactivating the spent carbon instead of incinerating it, there's much reduced carbon footprint. Ongoing in-house R&D and third-party analysis is enabling us to continually enhance our product range.
So we've talked a lot about our Filter Pure CH range. Again, we wanted to prove that the performance is indeed superior to a premium reagglomerated GAC that you typically find at a drinking water facility. So we work with a UK water company. They supplied real water samples from their sites. This isn't pure lab water. This is customer water. They identified 5 different PFAS in their water supply. You can see them mentioned at the bottom there. So different chain lengths, different functional groups. and up the y-axis is the removal of percentage at a set condition of the test. The light blue is a premium reagglomerated GAC you typically find at a drinking water site, and the dark green is the performance of our Filter Pure CH. And in every case, you can clearly see that the removal percentage is significantly higher with our surface modified carbons. The relative performance advantage increases with a shorter length. It's generally acknowledged that standard GAC isn't great for shorter chain PFAS molecules. That's one main reason why we develop these surface modifications, but they do help with all PFAS length as well. Looking at the example at the bottom left there, so shorter chain carboxylic acid head, with a reagglomerated GAC, you're getting 10 or maybe 12% the removal. With our CH range, you're getting a 200% uplift in the removal efficiency, so over 30%. It's still not fantastic, but if you want more than that, you can add more GAC, you can add more contact time, more filters. But it shows the step up in performance that clearly show the superior performance of our Filter Pure CH range. Don't take our word for it. We're winning multiple awards, not just for PFAS, but for our other innovations too. You can see some here from the last year or so. The biggest one, the highest profile, was a Global Green Apple Award, which we won last year. The event was in New Zealand. We won the UK event in late 2024. We were put forward as UK ambassadors, and we won the global events, beating some of the world's biggest companies. And this is specifically for our PFAS solution, search, capture, and destroy. So we're really proud of this. Obviously, activated carbon is a fairly niche technology, but we are leading the way and showing what it can be done, and that PureGen is at the cutting edge of what's possible with our technology. So again, zooming out a little bit, the way we work with customers, it really forms part of a three-pillar approach. We work in partnership. This has been mentioned a few times already. We want to build long-term, not simply selling a solution and walk away. We will work with customers, particularly on these difficult challenges like PFAS. We're all learning as we go along about the performance, the length, the bedtime and everything else. So we're getting data and working with customers to improve it. We have a comprehensive range of capabilities in terms of the very early stage to understanding the problem and specifying a solution through to implementing it and working with customers through to the reactivation and the waste handling stage. And yeah, innovation is the backbone of what we do, constantly looking to improve products, services, capabilities, and processes, and working with customers to share that. Just click on one more. So yeah, end-to-end services, we've alluded to many of these already. Expert carbon selection. Activated carbon isn't one thing. We have a range of hundreds of different carbon compounds, including the latest generation, and we help customers select the most appropriate solution. Fast, flexible, disruption-free mobile filtration, scalable, on demand, minimal downtime. In fact, if you have multiple mobile filters and they're piped properly, you can have zero downtime. You can bypass one while you're changing another out. And again, with our engineering capability, we can help with that. Cost-efficient carbon reactivation, reduce long-term carbon costs and significantly lower environmental impact. We didn't quantify that, but typically in excess of 90% carbon footprint saving by using reactivated carbon rather than the alternative, which is single use of an imported GAC, use it once and then either landfill or incinerate it. So a huge environmental driver. And as we perhaps alluded to earlier, we're the only people in the UK to have amber reactivation, that is non-potable. So we have a green kiln at Immingham for drinking water customers, and we have an amber kiln for everything else. So that's wastewater remediation, VOC, odor control. We're the only people in the UK to do that. Anyone else claiming to recycle carbon from those sectors is either incinerating them or sending them overseas. Site services, so if required by the customer, we can send our guys in, our experienced engineers, to help install or remove carbon or filters if required. That's both in the UK and overseas too. And in addition to manufacturing the filters, we can install all the peripherals if required. So if a site hasn't used carbon in their process before, they will probably need pipework, pumps, valves, fans, all those additional things. We can design, install, and manufacture all those quickly and efficiently. Again, we're unique in that capability in the UK, and we can offer that service overseas too. So yeah, very much end-to-end services.